And
Hi, everybody.
there you go. Thomas,
Hello, officially.
floor's yours.
Let's see if we'll go. Okay, we'll go back to the title here. I'll get started because I've only got about 25 minutes here. So, how Steam Play Proton makes gaming on Linux awesome. What I want to do here is go over some of the main components involved with Proton that kind of make your gaming experience on Linux work. There's a lot of components involved, and I think it would help a lot of people to have a general idea, especially those in the Linux world who like to tinker, to have an idea of where to look for certain things when trying to, maybe troubleshoot some things on gaming on Linux. So, a little intro about me. My name is Tom Kreider. I go by Glorious Eggroll online. I am the developer of ProtonGE, which is a fork of Proton. I also have my Nobara project, which is a fork of Fedora. It's gaming oriented. As odd as it may sound, my nickname is Eggy. It's stuck with me for many, many years. So, egg like a chicken egg, E. I'm currently an engineer at Red Hat. I've been there for going on about 5 years now. And my job at Red Hat has nothing to do with gaming. But in my free time, I dedicate most of my free time to these two main projects, which have been a lot of fun for me. Personally, I've been using Linux for probably a little bit over 2 decades, 20 plus years. My goal is to it's not so much to talk about my projects, but rather to go over the main components in Steam Play and Proton that allow Windows games to run and give you a basic overview of what they do. So, first things, a big honking chart. This is the first half of the chart. We're going to go over this first. So you have to have an understanding of what happens on the Windows side first, because a lot of the games most of the games that you're running in Steam Play Proton are through their Windows executables that have been translated through Wine. So we've got the game, and that's where it starts. The game has 3 main components. There are several Windows APIs that are used that Wine does, that Wine translates. But the main 3 are you've got your graphics, your audio, and your controls, your device input. Those on the Windows side generally go through DirectX on Windows. DirectX then separates them into 3 main components, which are Direct3D, which is versions 9, 10, 11, and 12. You do have older versions, but most of the time it's those 4. You've got X audio for your audio, and then you have D input and X input for your controller input. So we're going to break down this chart a little bit with the first part. I just explained these, so there you go. You've got those 3 components that I just told you about. I don't know why I did double slide for that, but there you go. More on DirectX. So as I mentioned, the DirectX API breaks down these 3 main components into DirectX compatible subcomponents like so. You've got Direct3D, which handles DirectX 9, 10, 11, 12. X audio handles audio. D input and X input handle the controller input. And then we have an additional note here for graphics. There are some games on Windows that don't use DirectX or don't use Direct3D portion of DirectX. Instead, they use either the older OpenGL or the more current and more popular now, Vulkan. Thank you, Valve. You guys have been awesome with getting that a lot more popular. But for those games that use those directly, Wine does do some minimum translation, but it can pass most things directly to Linux because Linux is able to run those natively as opposed to Direct3D where it cannot. So with specific regards to that, again, OpenGL and Vulkan kind of they don't have to go through DirectX. And now a big honking chart of the Linux stuff, the part that everybody wants to see. This is a much bigger part of the chart, obviously. I'm sorry if people can't see this. I know the chart is kind of small even though it's blown up here. But we'll break it down a little bit more. So we've got Wine, which is where the DirectX stuff gets inputted. And Wine handles a bunch of different Windows APIs. There is a presenter later today, Eric Hiller. I would recommend if you're interested in seeing a lot more detail on the various Windows APIs that Wine handles, to check out his presentation tomorrow. He also has one later today regarding the different branches of Proton, so I would recommend checking that one out as well if you're interested in this kind of thing. But we're going to go over just the three main ones that I mentioned before. So we've got WinD3D, right? So Legacy, the way that it worked for Legacy is Direct3D 9, 10, and 11 originally went through WinD3D. WinD3D is still implemented, but the difference between WinD3D and the newer VKD3D and DXVK is that WinD3D was for OpenGL. So before VKD3D and before DXVK existed, that's how games would get translated. They would translate the DirectX calls to OpenGL through WinD3D. Nowadays, especially with Proton specifically, we use DXVK and VKD3D for translating those DirectX calls to Vulkan. So this is just an explanation here of Wine. Its acronym, Wine is not an emulator. It's a compatibility layer capable of running Windows applications on several POSIX compliant operating systems. This is pulled from Wikipedia. You can probably bring this up if you need to. I'm trying to get through all my content here because I got quite a few slides. But that is just a definition of Wine and Wine's website. This is the core of what makes up Proton. This is the bread and butter. More on Wine's API translations. In this specific regard, DirectX API is considered a Windows API. In addition to Windows' own API, additional APIs existing outside DirectX, DirectX is therefore handled by Wine the same as those other Windows APIs. For the three main components we discussed, graphics, audio, controls, Wine takes those API calls and translates them and sends the translated calls to native Linux libraries, which then pass those calls onto the Linux systems drivers. Wine translation layers for graphics. So now we're going to go into a little bit more detail on the current gen graphics side. I explained the WinD3D portion, which is number one. That one is not really used in Proton. There are overrides that there's an environment override that you can use if you want to try it, but generally we want to try to use either DXVK or VKD3D if possible. The WinD3D backend is more of kind of like a fallback to try, and then it also helps with bug reporting. Like if an older game you try runs in WinD3D but doesn't run in DXVK or Proton, that's definitely something that you would want to do a bug report on because it should work in that regard. Again, so just to separate the difference between DXVK and VKD3D, we'll touch on number two first. DXVK is an external translation layer used by Proton for translating Direct3D 9, 10, and 11 on Vulkan. Or to Vulkan, excuse me. DirectX 12 in specific is handled by VKD3D, which is a second portion, and we'll get to that in a moment. Proton uses DXVK as a replacement for WinD3D, as I said, mainly for the advantage of being able to use Vulkan instead of OpenGL. And because DXVK is specifically aimed at gaming performance and optimization, well, I'll tell you a little bit about Damavan in a minute. Damavan, here, let me back up a minute. So Damavan is a work-in-progress replacement for WinD3D that kind of does the same thing that DXVK does, but the difference is DXVK is aimed for gaming, whereas Damavan is aimed more as a traditional WinD3D backend. It's more so meant for, if you want a game, but you also want to try and run basic Windows applications, because we know that Wine itself is not just for games. And that's why Proton specifically uses DXVK rather than using the Damavan backend. So yeah, that's what I was explaining there. Now that you know about Damavan, again, that's why we use DXVK instead of Damavan. Let's see, Wine translation for graphics layers continued. Now we'll get into the VKD3D portion. So VKD3D specifically handles the DirectX 12 portion. So an important thing for games in particular is if you are running a game and maybe you're having a problem, maybe it won't load, or maybe you see graphic glitches or something, it's important to know or to try and find out which version of DirectX or Direct3D that it's running, because that can kind of give you an idea of where to report bugs. For example, if the game's an older one or it's running DX9, 10, 11, then it might be a DXVK bug. But if it's running DirectX 12, then it would be a VKD3D bug. The bottom line, regardless, on the Proton side, is that generally we would want you to report Proton-specific bugs on the Proton tracker, and then Valve does have engineers that can further direct those to the appropriate people that need to take a look. But outside of Proton, which is where stuff that I work on comes in, like not just ProtonGE, but also WineGE, it's helpful for me to know if the game is DirectX 9, 10, or 11, because then we can direct a bug report directly to those projects, because while they are part of Proton, they also have their own individual bug trackers outside of Proton. There's a couple of parts to VKD3D. So that Wine has, CodeWeavers, the developers of Wine, they have their own, the original branch of VKD3D. And that has a couple of different components that are part of it. And then Proton specifically it includes that, but it also has VKD3D Proton. And VKD3D Proton is actually just one part of the full list of components that make up VKD3D. I feel like I missed Okay, so yeah, that's what I was trying to get at. So VKD3D itself has two major parts. There's a couple of other parts, but the two major parts are VKD3D itself, which has the API translation layer, and then VKD3D shader. VKD3D shader is the shader compiler. It's used to compile or recompile shaders between different formats. And once the translation is, the VKD3D is used in combination with VKD3D shader. And so the job of VKD3 Proton is kind of a drop-in replacement for the translation portion of the original VKD3D, specifically aimed for gaming. And again, that's why both of them are, if you look in the GitHub repo for Proton, you'll see both VKD3D Proton and VKD3D are in there. And people who maybe didn't know the difference between the two would wonder why. Well, that's why. It's because VKD3D Proton is just the translation portion. So audio layers. Again, so Wine translates this, and it goes through a project called F-Audio. When SteamPlay Proton first started, originally audio was handled by Wine's own internal API translation layer for X-Audio. Unfortunately, this layer, it had quite a few problems, and we needed a new solution. This is actually kind of what got me started on working on Proton a little bit more, because I wanted Warframe to work, and Warframe had some problems with 64-bit audio. And so I kept reporting issues with it until, it had problems with DXVK too, but eventually I kept reporting and getting those things eventually fixed. And thankfully, F-Audio, once it was in a very good, usable state, many distros picked it up and started finally shipping it, which was great. And then on top of that, Wine implemented it directly into Wine as a new audio backend replacement. So F-Audio has been awesome since then. We're happy with it. It's been a blessing. Let's see here. So there's a couple of other audio components. The way that the audio portion works is it goes through F-Audio, and then from F-Audio it gets passed on to the system's audio handlers. Well, it gets passed on to SDL first, and then it goes to the system's audio handlers, such as ALSA, Pulse, Pipewire. There are also other components beyond X-Audio that Wine still translates directly and sends directly to those other ALSA, Pulse Audio, or Pipewire. However, X Audio is the main component that's used in most games. Wine translation layers for controls, controller inputs. Generally, Proton specifically uses SDL as backend. Generally, controller API calls are translated from Wine to the open source SDL library, which then passes the calls to the device and the driver. This is also how the Steam overlay is able to set controls via SDL. In addition to the default SDL backend, Proton has been patched to allow a few specific devices to use HiDraw rather than SDL for better performance, such as Sony controllers. On top of the input and exput, Windows Gaming Input API has also been implemented into Wine. Native APIs and Wine. We've got, as mentioned, if a game uses a graphics or other API that is native to Linux, Wine has no need to really translate anything, at least nothing major. It does have some code that it uses, but nothing that causes any kind of crazy amount of overhead or anything like that. Open source APIs such as OpenGL, Vulkan, OpenAL, SDL, and so on can have their API calls passed directly from the game through Wine to the libraries that handle the calls without any such major translation layers needed. Like again, I said, there's some minor stuff that happens there, but nothing too crazy. Gaming-specific features. These are things that a lot of gamers are really, really adamant on having. The new features that come out for various different graphics cards, different companies that have them. FSR, DLSS, XESS. Regarding FSR in particular, I get this question all the time because there's now 3 iterations of FSR. They want to know if the newer versions of FSR can be implemented in Wine, and that's a no. The reason for that is the first version that we had, it allowed to be implemented without being inside the game. With FSR 2 and 3 and further versions, they have to be implemented specifically within the game. Also with FSR 1, the original scaler for FSR 1 was supposed to be a patch for Wine. The original creator of that patch set, he then decided, okay, we're going to move this over to GameScope instead. So that's why GameScope has FSR compatibility. What we did with ProtonGE was we kept that patch set because at the time, some people did not want to use GameScope. They wanted to be able to still use FSR, but not use GameScope for whatever reason they had. Maybe they had an older system. Maybe they were afraid of input lag or whatever, or overhead. Regardless of that, there aren't really any input problems now with GameScope. It did have some in its early life, but now it's pretty much had most of that ironed out, and GameScope has been awesome. NVIDIA DLSS is the same issue with FSR 2.0 onward, except for DLSS has never had a specific patch set. It's always been in-game only, but it does work. Intel XESS is, again, the same. It has to be implemented in the game, but it does work. Adaptive sync and variable refresh rate. This is aka FreeSync, VRR. FreeSync currently works on Wayland for AMD and Intel GPUs using the open source Mesa driver stack. For desktop usage, this also depends on what desktop your environment you're using. In KDE, this is implemented. In GNOME, there's a long-standing merge request that is still being worked on. It's a constant work in progress, and it's been pending for like 2 years. But it is something that people have been really, really pushing to try and get into GNOME. Let's see. NVIDIA G-Sync on Wayland. It's currently implemented in their recently released beta driver, if anybody's been trying that. There have been some problems. They're still working on it. I know they're working really hard to actually try and get that working in Wayland. It's been trouble, but it's good to see that they finally at least brought it forward and they're trying to get it working. Resizable bar, smart access memory, that works. That's worked for probably maybe a year and a half to 2 years now. That's been awesome to have, especially with the new, well, not new now, but the Intel GPUs that came out that heavily rely on it. But yes, resizable bar works. Ray tracing. Ray tracing has been a pain point for a lot of people, because they have cards, especially, well, not so much on the NVIDIA side. The ray tracing has worked on NVIDIA's GPUs for, whatever drivers they're using. But on the Mesa side, it's taken a while to get there, but we are finally getting around to it. We do have games that are performant with ray tracing and generally work pretty well. I personally, Doom Eternal works great for me for ray tracing on any decent end GPU from the AMD stack side. So I'm actually personally really happy to see ray tracing. I know some people don't really care for ray tracing. They'd rather have like the high FPS and the performance rather than seeing the cool graphics. But sometimes you get those games that just look really freaking cool, and you want to see the ray tracing in it. Okay, so the full screen hack. Full screen hack is something that's been in Proton specifically. You won't find this in normal Wine. It's also in WineGE because we base off Proton. What this does is it takes the resolution for some of the older games. Say you have a game, for example, this one is Age of Mythology, and it runs, by default, it runs in 1024 by 768. If you were to open this in normal Wine, or you didn't have a full screen hack, and maybe you weren't using Wayland or something, it would skew the screens, skew the resolution so that it's stretched and look weird. You don't want that. It's going to look weird when you're playing. It messes with the mouse input. So what the full screen hack does is it is able to take those resolutions and properly render them to whatever aspect ratio your screen is, and it just gives you, your black bars on the space that's not used. So that way you can play the game properly, it still functions properly, your mouse is working properly, and the game is displayed as it's originally intended without any weird skewing. I've got 3 minutes here. The Steam runtime. So the last piece of the puzzle is Valve's Soldier and Sniper Steam runtimes. When Proton runs a game, it runs it in a custom container environment that Valve has developed called Pressure Vessel. This is similar to Docker in the fact that you can mount the runtime containers in Docker. The reason this is done is because it allows distro-agnostic experience, meaning the same libraries are used for running Wine and Proton components within the container, preventing breakage that would otherwise be caused by a versioning difference across different distributions. For example, glibc. You might, if you're running maybe Fedora or Arch or a distro that generally keeps glibc up to date, you might have like version 2.34, 2.35, 2.36, which is fine, but if Wine was built on 2.36 and you're running a distro that's running 2.31 glibc, you would hit a problem where Wine can't run because it's expecting a newer version of glibc. Steam Runtime solves that by running it, and it runs a specific glibc translation within the container that Valve have developed. It's really, really cool. We do something similar in WineGE. It's not nearly as advanced as that, but we do build on, WineGE, we use a container that's based off of Debian 11, which ships with glibc 2.31, and that allows a lot of the games to Wine itself to basically run on the newer distros that have a version newer than 2.31. It's still kind of a pain point because we're still going to get people that maybe they're running an ancient distro or haven't upgraded in forever and they have a version that's older than 2.31. But for most people, that's how we resolve it outside of Valve's Pressure Vessel runtime. Anti-cheat. Anti-cheat's another big one. So while the anti-cheat has been a consistent pain point for many games, Valve has implemented bridges for two of the major anti-cheat technologies, Easy Anti-Cheat and BattleEye. And yes, they spell it like that. I don't know why they took the extra E out of Battle. Ultimately, this is up to the game developer to reach out to EAC and or BattleEye to enable compatibility with the bridge in order for it to work. That's a hit or miss, and it's this is a pain point because now you even think, okay, well, we have the bridges there, it just depends on the developer, and some developers just really, for one reason or another, decide not to turn it on. For any developers that are out there, we hope that you please consider. It would be amazing to be able to get games running like that on Linux. We do have some great examples that are already working. We've got, obviously Apex Legends, Halo, the Master Chief Collection, New World, Arma 3, DayZ, Division 2, lots of them. There is a website, Are We Anti-Cheat Yet? This is basically an anti-cheat tracker to see what kind of anti-cheat different games use and what their status is, if they've enabled it on Linux or not. It's a really good resource for checking that. Game compatibility. Besides the anti-cheat, you can check most games if they're compatible through ProtonDB. For new users, this is really a kind of a useful tool because it'll tell you if a game works out of the box or if it has maybe different, maybe it needs some tweaks, maybe it needs a specific Proton version. It's really, really helpful, especially, again, for new users. And I'm sorry, we're running out of time here. I think these are the last slides I have anyway. We do have different places for bug reports. This is for mostly outside of Wine. If you could, if you're interested, again, look into those components, figure out which ones you need, and try to use these different URLs for all the different specific bug reporting. And that's it. That's the end. Wow, right on time. Thank you very, very much. I appreciate you guys' time and appreciate you coming out.
All right, thank you.